Today we're going to talk about solving equations by graphing. You can use a system of linear equations to solve an equation with variables on both sides. In order to do this, you have to have an equation with variables on both sides, like I have an x on both sides here, and you're going to write it as two separate equations. So I have ax plus b equals cx plus d. I know they're equal to each other. I'm going to make them both equal to y. So I have y equals ax plus b, and I have y equals cx plus d. Then I graph this system of linear equations and find the intersection. And where they intersect, the x value of that point is my x value that is a solution for my equation. So let's see how this works. So here I've got one equation with variables on both sides. Negative x plus 1 equals 2x minus 5. I'm going to write it as two separate equations. Y equals negative x plus 1. And I'm going to write y equals 2x minus 5. And I'm going to graph both of these on this graph here. So I'm going to start with y equals negative x plus 1. It has a y-intercept of 1 and a slope of negative 1. So it's going through all these points here. And I can continue to connect it so it spans my entire graph. Now I'm going to graph my 2x minus 5. So I have a y-intercept of negative 5 and a slope of 2. So up 2 and over 1, up 2 and over 1, up 2 and over 1. And even before I connect it, I can see where they're going to intersect here. And it looks like they're crossing at the point 2 comma negative 1. So basically the one I care about here is my x value, because I had an x in my original equation. I get x equals 2. So I think I've found my solution. I just want to check my answer. So if I plug 2 in for x into my original equation, I'll get negative 2 plus 1 equals 2 times 2 minus 5. Negative 2 plus 1 gives me negative 1. 2 times 2 gives me 4. And 4 minus 5 also gives me negative 1. So my answer checks out. So here x equals 2 in this equation. We can also solve absolute value equations by graphing. So we saw equations like this in a previous section, and what we're actually going to do here is set up two different equations. So I can have x plus 1 equals 2x minus 4, where they're both positive, or basically this is like the both positive, both negative version. Or I can have one that's positive and one that it's opposite, so negative 2x plus 4. And from each of these, I'm going to set up two separate equations. So here I can have y equals x plus 1, and I can have y equals 2x minus 4. So I'm going to set these up on my graph. So here I have a y-intercept of 1, and my slope is going up by 1. So, oops. Not the best of lines, but here I have a y-intercept of negative 4, which is a little bit off my graph, and a slope of 2. So my y-intercept is going to be more like down here, but I'm going to go up 2 and over 1 and up 2 and over 1, and now I'm back on the graph, up 2 and over 1, up 2 and over 1, up 2 and over 1, and I see which point they're going to share here. So it looks like this point is where they cross, and this point is actually at 5 comma 6. So what I really care about is the x value, x equals 5. So I'm going to test it out and see if it works here. Back in my original equation. So in my original equation, I had the absolute value of x plus 1, so 5 plus 1, equals the absolute value of 2 times x, So 5 minus 4. So 5 plus 1 gives me the absolute value of 6. 2 times 5 is 10, minus 4 is 6. And the absolute value of 6 is 6 and 6, so it checks out. So one possible solution for x here is 5. But I may have another possible solution. Let's take a look at this other equation we set up. So I'll also have y equals x plus 1, same equation from my last graph. My second equation will be a little different though, negative 2x plus 4 equals y. So let's graph these guys. So I have an y-intercept of 1 and a slope of 1. And then I also have my second equation with a y-intercept of 4 and a slope of negative 2. So these guys are crossing at the point 2, 1. I'm sorry, 1, 2. My mistake. So x is what I really care about. I get an x value of 1. So let's test it out and see if it actually works in my original equation, if it is another solution. So I would have the absolute value of x plus 1, that'd be 1 plus 1, equals the absolute value of 2 times 1 minus 4. So 1 plus 1 is the absolute value of 2. 2 times 1 is 2, minus 4 is negative 2. The absolute value of 2 is 2, and the absolute value of negative 2 is 2, so it checks out. So I have two possible answers here. I have x equals 5, and I have x equals 1. So two solutions.